Good afternoon, everyone. My name is Jeff Brown, and I work on the Grails development team at Pivotal. And what I'm going to be talking about this afternoon is probably my favorite part of the whole, my favorite feature in all of Groovy, and that is metaprogramming. There are really two fundamentally different types of metaprogramming that Groovy supports. Groovy has a really rich set of runtime metaprogramming capabilities that we're going to explore. And it also has a really powerful compile time metaprogramming capabilities, which we're really not going to get into this afternoon. But be aware that, Groovy does, in fact, support compile time metaprogramming. There's lots of really cool stuff you can do at compile time. We're going to focus on runtime metaprogramming in this session. So I'm not going to spend a whole lot of time looking at slides. There are a few here that represent just kind of the really high level of what areas we're going to explore, but we're going to spend most of our time in an IDE running real code, which is a much more interesting way to explore a lot of this. So the first thing I want to talk about are MOP hooks. So the MOP stands for the Meta Object Protocol. So anytime you make a method call from Groovy, anytime you make a method call from Groovy, or anytime you do property access from Groovy, if you assign a value to a property in some other object or retrieve the value of a property, if that is being initiated from Groovy code, even if the thing at the other end is a Java object or a Scala object, it doesn't matter what language the other thing was written in, if the method call is being initiated from Groovy, that method call, by default anyway, will go through the MOP, the Meta Object Protocol. And the MOP is responsible for all of Groovy's really powerful and flexible dynamic dispatch stuff. So with a static language like Java, if you create an instance of an object and invoke a method on that object, so you create a new string buffer s equals new string buffer s.append, and you pass a string as an argument, right? You're invoking a method on that object reference. When the compiler compiles that code, it generates instructions to go find the append method in the string buffer class and execute it, right? And pass these arguments along. The compiler generates instructions that goes and at runtime finds the append method, and that's the code that gets executed. That's not what happens in Groovy. In Groovy, you can write that exact same code, string buffer s equals new string buffer s.append some string, and the results might be the same or they might not, because you're not necessarily going to execute the append method in the string buffer class when you write code like that. It could be that append method, that call to append, will be intercepted by something, and that code would execute instead of the append method in the real string buffer class. And it's the MOP that is handling that request. So when you make a method call, when you express a method call in your source code, what the compiler generates for that isn't a call directly to the method that you tried to invoke. It's a call to Groovy's runtime mechanism that says, here's an object reference, here's a method name that we'd like to invoke, and here are some arguments. Make that happen. And the MOP might end up invoking the real method that would have been invoked had this code been Java, or it might do something else. And we're going to explore a lot of what some of those other options might be. So you can participate in the MOP. There are a number of ways you can participate in what's going on in the Meta Object Protocol. And one way is by leveraging these so-called MOP hooks. There are some special methods that we're going to explore and then play with some code and figure out some interesting ways to take advantage of these methods. So in Groovy code, when you do something like obj.someProperty equals 42, that is kind of like invoking the setProperty method on that object reference and passing a string as the first argument, and that string describes the value of that string represents the name of the property that you are trying to assign a value to. And then the second argument, 42 in this case, is the value you're trying to assign to that property. So you would never type the second line, right? You type the first line, and one thing that might happen as a result of that is the second line, something like what's represented in the second line gets executed. Likewise, when you're retrieving the value of a property, one thing that might happen when you retrieve the value of a property is Groovy might invoke a method called getProperty on that object and pass a string as an argument. And the string, again, represents the name of the property whose value you're trying to retrieve. And then finally, there's another MOP hook that is the method missing method. So if you invoke a method that does not exist on an object reference, so maybe some method doesn't exist, right? We're invoking a method named some method. If that method does not exist, normally what would happen is a missing method exception will be thrown. But if the class that obj is an instance of happens to have a method missing method in it, instead of throwing a missing method exception, the MOP will invoke the method missing method. So the author of the method missing method is expressing that they want to participate in intercepting calls to methods that don't exist. All right, so that's just a really quick high-level introduction of those ideas, and we're going to explore why those features exist, and we're going to write some code that takes advantage of those, and hopefully the motivation for why those are, the explanation for why those are really cool and really powerful will become more clear as we move along here. So I'm going to start by writing a simple script that creates an instance of a class called Expando, and we'll say hometown equals STL. I live just outside of St. Louis. So I can I can create an instance of this Expando class and just make up properties and assign them values. There is no hometown property in the Expando class, I assure you, but that code will work, right? I can just make up a property and assign it a value. I want to be clear, it's not the case that this is how Groovy objects in general behave, right? It's not the case that in Groovy you can always just make up properties and assign them values. That's not the case. It turns out there's code in the Expando class in particular to support that. And we'll see what that code looks like. So let's print the value of that hometown property. So on line 3, we're assigning a value to a property that doesn't exist. And on line 5, I'm retrieving the value of that property that doesn't exist. And when I run this, we see the output there is hometown STL. So it appears to have worked, right? I can assign a value to a property that doesn't exist, and I can retrieve that value later. And these metaprogramming hooks are how that's happening. It turns out that there is a set property method in the Expando class. So when you assign a value to a property, it doesn't matter what the property name is, you can assign a value to any property, and this happens, right? It's like calling, on our Expando, it's like calling ex.setProperty, and then passing hometown as the first argument and STL as the second argument. And then when we retrieve the value of that property, it's like calling ex.getProperty hometown. All right, so I've got a class called Spring1 Expando. So we're going to write our own Expando class. We're going to pretend that the Expando class doesn't exist. That's a real class that's provided with Groovy. But we're going to ignore that, and we're going to implement our own version of that class. And that's going to allow us to do some really interesting things with these MOP hooks that we're talking about. All right, so I've got Spring1 Expando that's empty. We're going to write a unit test that describes how we want the thing to behave. All right, so I might say def ex equals new Spring1 Expando, ex.name equals Jeff, and then I want to express that I expect the value of that to be equal to Jeff when I retrieve it later. Right? That looks like a valid test. On line 10, I'm creating an instance of our new class. On line 11, I'm assigning a value to a property that doesn't exist. And on line 14, I'm making an assertion about what I expect the value of that property to be. So if I run this test should fail. Right? And it failed with a missing property exception right here on line 11. This right here threw a missing property exception. Because as I said before, it's not the case that all objects in Groovy behave such that you can just make up properties and assign them values. But what I can do as the author of the Spring1 Expando class is I can implement this setProperty method like that. We'll leave it empty for now and rerun this test. The test is still going to fail, and it's still going to fail with a missing property exception, but now it's failing on line 14, which is this bit right here. So line 11 succeeded. Right? At least it didn't fail. Nothing interesting really happened when I assigned a value to the name property, because what's happened when line 11 here executes is this was called, and that method's empty, so it doesn't do anything, but it also doesn't result in an exception or any sort of error. I can assign a value to any property at all, right? ex.foo equals 42, that'll work. So we're getting a missing method, no such property, missing property exception is what we're getting here, right? When I try to retrieve the value of a property that doesn't exist, we're getting an exception. So now if I were to say def get property, and right now I'm just going to hard code that and have it return 42, so it's returning something. All right, so now our test failed because I've made a claim that I think that ex.name should be equal to Jeff, but it's actually equal to 42. Right, so this is calling ex.set property, and this is calling ex.get property. Yes?
A second ago, you had the second property under the x.name.
I did?
Would that work? Because there's only one set property.
Yeah, so that method's just being called over and over again, right? I can say, I can call it as many times as I like, right? Yep, so I can assign a value to as many properties as makes sense. But right now, that method's empty. Nothing interesting is happening. And with just 2 or 3 lines of code, we can make this work. So let me type those 2 lines of code, and then we'll back up and talk about what's going on here. All right, let's run our test. Green bar, that's good. So let's just step through this and make sure that we understand what's going on. So on line 5, I've just declared a property in this class called dynamic props, and there's nothing magic about that name. It's just a protected field I've declared in this class. Could be called anything. And I've initialized it with an empty map, right? So dynamic props is an empty map. Every time set property is called, what I'm doing is I'm putting a new entry in the map where the key is prop name and the value is val. So in this case here, where I said name equals Jeff, prop name will be name and val will be Jeff. So it's like having done this. Oop, that's not what I wanted. Right? Something like that is happening. I've hard-coded the values there, of course, but that's what's happening. We're putting a new entry in the map where the key is the name of the property that we assigned a value to, and the value is the value that we assigned to that property, right? And then in the get property method, I'm simply returning whatever value is in the map that's associated with this key. So again, the value of prop name in our test case is going to be the word name, because I retrieved the value of the name property. Does that make sense? Any comments about that? All right, very good. Let's write another test that describes another piece of behavior that the real expando class supports. So we'll create another instance of the Spring1 expando. And this time I'm going to say ex.multiply numbers equals x, y, x times y. We'll come back to that in just a second. All right, so, and the real expando behaves just like I'm describing here. So I want to create an instance of the Spring1 expando class and assign a value to a property that doesn't exist, right? So multiply numbers is a property that does not exist, and I'm assigning it a value. On line 11, I'm assigning a value to a property that doesn't exist, and the value that I'm assigning is a string, right? On line 11, the value that I'm assigning to the name property is the string Jeff. The same sort of thing is happening on line 20, right? I'm assigning a value to a property that doesn't exist, but in the case of line 20, the value that I'm assigning is a closure. It's not a string or anything else, it's a closure. And the way the expando class works is when you assign a value to a property like this and the value is a closure, then effectively what you've done is you've added a method to this particular expando object. Not the expando class in general, but this particular expando object. You've added a method to this object, and it's as if that's the body of the method, right? So I want to be able to run this and have it pass, and it's not going to pass right now. But we can make it pass with very, very little code, right? So when I ran this test, we got a missing method exception, and the missing method exception is coming from right here on line 25. There is no multiply numbers method in the Spring 1 Expando class, so we get a missing method exception when we try to invoke that method that does not exist. But we can make that work by implementing method missing. Right? So now when I run the test, it's still going to fail, but it fails because multiply numbers returned null. Right? Whatever is returned from here is what's being returned from that call to multiply numbers. So the assertion here shows me that the return value was 99. I expected it to be 36. It's 99 because I've hard-coded the return value right here. So let me type about 3 more lines of code here. Equals dynamic props. All right, come back to that in just a minute. Let's watch our test pass, and it did pass, right? Both of our tests are passing now. We've got a green bar. So in my test, when I invoke ex.multiply numbers and pass 4 and 9 as arguments, there is no multiply numbers in the Spring 1 Expando class. So normally what would happen is Groovy would throw a missing method exception. But as I said before, if there's a missing method in the class that you're interacting with, then instead of throwing a missing method exception, Groovy will invoke method missing, and then it's up to you to do whatever you want to do inside of method missing. So when that happens, the first argument to method missing will be a string that represents the name of the method, multiply numbers. The second argument is really an object array. It's like this. You don't have to statically type it, but that's what it is. It's an object array that includes all of the arguments that were passed to the method invocation. So back here, remember, we're passing the numbers 4 and 9 as arguments to the multiply numbers method. So the value of args will be an object array that has those two elements in it, 4 and 9. So what I'm doing on line 16 is looking in our dynamic properties map to see if there's a value associated with the key multiply numbers, right? Method name will be multiply numbers. And there will be a key in the map called multiply numbers because of this. Right? When I said ex.multiply numbers equals closure, that executed this code right here, where prop name is multiply numbers and val is that closure. So when line 16 executes, the value of prop is going to be that closure. So I've got a small bit of error checking here to make sure that it is a closure, and if it is, invoke that closure and pass these arguments along. Right? Does that make sense? It's good?
The asterisk is to the spread operator?
Yeah, the asterisk is the spread operator. So it's like we did this, right? So if I said arg sub 0, args sub 1, that's still going to work. Let me comment that out. So that's our implementation right now, and it's still going to work. We'll run our test to verify that, and it did. But now we've sort of hard-coded this to only work with closures that accept 2 arguments. That's no good. So one thing I could do is I could interrogate the closure. There's a property, what is it? It's maximum number of parameters, I think. Maximum number of parameters. I can do something like that, and then I can have a bunch of different cases. If the maximum number of parameters is 1, do one thing. If it's 2, do another thing. But that's crazy. Why? There's no good reason to do that. What happens when you use the spread operator in this context is the object array, args is an object array, and it's not the case that that object array is being passed to the closure. The individual elements of the object array are basically being pulled from the object array and passed as discrete arguments into the closure. So 2 different values are being passed into our closure, the number 4 and the number 9. That's what's going on with the spread operator there. Yeah?
If we pass 3 arguments, will we get the missing method exception again?
So the question is, if we pass 3 arguments, will we get the missing method exception again? And we will, unless we change this up here. So let's look at 2 iterations of that. So we'll say we want this to be equal to 360, right? 4, 9, and 10. Now if I run our test, it's going to fail. There we go. We got a missing method exception, and the line number is right here because this invocation actually worked, right? That leads to method missing. The exception's actually coming from right here because that is trying to do this on the closure. It's trying to invoke the call method and pass 3 arguments, but the call method on this particular closure only accepts 2 arguments. So we can make this work by doing this. Now it's valid, I think. There, and that worked. So your invocation has to match just like with a real method, right? When you define a method, when you try to invoke that method, you've got to pass the appropriate number of arguments. Right? Any other questions about this? Right? So we're participating in Groovy's dynamic dispatch. As the author of this class, we're saying anytime someone tries to assign a value to a property on an instance of this class, let me participate in that. Right? And anytime someone tries to retrieve the value of a property, let me participate in that. And if someone invokes a method that doesn't exist, let me handle that. And we could add an else block here that throws a missing method exception if we like. We get to decide what to do if this property either doesn't exist or isn't a closure. But so if we go any further down that path, we're just doing tedious error handling stuff that isn't really related to Groovy's metaprogramming that I want to talk about. All right. Let's talk about closures and closure delegates, and then that's going to open up several areas that we're going to want to cover. But in order to do that, we need to cover some basics about closures and closure delegates and so forth. So if we were just using closures, right? Over here, this is a closure, right? We're going to learn some of the details about that. So if I were to say closure equals all right, so if I run that, what's going to happen? Any guess? You look like you want to guess, Ken. No idea. All right. Yeah, it's nothing. So I just ran it and nothing happened because I haven't even invoked the closure yet, right? I just defined a closure, but I didn't run it. Now, if I run it, we're going to get an error. And the error that we get is missing method exception, no method called append. Right here, I'm calling a method that does not exist. So append is not a keyword or anything. It doesn't mean anything in Groovy. It's just as if I had done this, right? We're just invoking something that does not exist, right? But I chose append on purpose. We'll see why here. Let's do this. All right, now let's run this. And we didn't get an error. We see the value of buffer is line 1 / line 1 and line 2 are in that string buffer. So let's figure out what's going on there. So every closure, there are 3 properties that closures have that we're going to talk about. We're going to spend most of our time talking about the delegate, and then I'll introduce the other 2, and we'll see how they all relate to each other. Every closure has a delegate associated with it. Every closure has a delegate associated with it. That delegate gets an opportunity to respond to method calls that are made inside the closure. And I'm going to be speaking in terms of method calls, but everything I'm going to talk about applies to property access the same way that it applies to method calls. But I'm going to focus on method calls. The delegate gets an opportunity to respond to method calls that are made while the closure is executing. So what that means is right here on line 8, when I invoke the closure, this is the first thing that happens. One of the things that, if this were in a class and there really were an append method in that class, this would be calling that append method. But there is no append method in this context that we're looking at here, which is why we got a missing method exception the first time I ran this. But one of the things that might happen when this closure is executing and the append method can't be found is the MOP, Groovy's dispatch mechanism, is going to interrogate the delegate and ask it, hey, if someone were to invoke the append method and pass a string argument, could you respond to that, right? Can you respond to that method call? So a string buffer can, in fact, respond to that method call, right? There's an append method in the string buffer class that is compatible with a string argument. So instead of throwing a missing method exception, line 2 is actually interacting with this string buffer that didn't even exist when the closure was defined, right? The string buffer wasn't created until later, until we got down to line 6. So the delegate gets an opportunity to respond to method calls that are made while the closure is executing. I want to get in a real class here to explore the next bit of this. We'll do this. I want to be inside of a class as opposed to a script. New closure demo. All right, we'll do something like that. And we'll do the same sort of thing I just did in the script. When I run this, we should get a missing method exception. And we did. It says no method append. Right here, we're calling a method that does not exist on lines 7 and 8. We never did get to line 8. Right? So now if I create a string buffer, like that. Now we should be back in business, or at least caught up to where we were in the script. Okay, so that worked. One question that we need to understand is what would happen if there really were an append method, like this. Right? Something like that. All right, so now when we run this, at least there are 3 reasonable options of what might happen, at least 3. One thing that might happen, really the question is what happens when line 11 executes? One thing that might happen is that might result in calling this method. It might call the append method on the string buffer. It might call both. And I guess another reasonable option is maybe Groovy will look at that call and say it's ambiguous, I don't know where to send this, and you'll get some kind of error. So the last one doesn't happen. But the other 2 seem like reasonable options. The other 3 seem like reasonable options. But let's see what actually does happen. So it looks like the append method was invoked twice. Why don't I see any? Oh, yeah, there it is. The append method was invoked twice. The string buffer is empty, right? The string buffer never was interacted with. So from that, it looks like the delegate only gets to participate if the method can't be found elsewhere. That's what this seems to demonstrate. And that's kind of true, but kind of not. So we need to explore the other 2 properties that I mentioned we'd get to earlier to understand that. So every closure has a delegate, and every closure has an owner. The owner is a read-only property. You would never assign it a value, but it's as if you did this every time you created a closure. Every time you create a closure, immediately after you're done, you assign a value to the owner, and the owner is always this. It's always the thing that created the closure. So line 14 doesn't need to be there. It's as if you did that every time you create a closure. So every closure has an owner, and the value of the owner property is whatever it is that created the closure. In this case, it's going to be an instance of the closure demo class. While the closure is executing, those are the only 2 things that get to respond to method calls that are made inside the closure. The owner gets opportunities to respond to method calls, and the delegate gets opportunities to respond to method calls, and that's it. Those are the only 2 things that could possibly respond to the method calls on lines 11 and 12. And from the test we just ran, it looks like the owner wins. If they both can respond to the method, the owner wins. And he kind of does, but there's a little bit more to it. So the last piece of this puzzle is this. Strategy equals. All right, so I'm assigning a value to a property called resolve strategy. So the only 3 properties that we're interested in are delegate, owner, and resolve strategy. Delegate, owner, and resolve strategy. There are 4 possible values for the resolve strategy, and we'll talk about all 4 of them. It'll all make perfect sense here in just a moment. So if I run this as written, we see that the append method in the class that we're writing is what's being called. The delegate is never being interacted with, and we can tell that because the value right here is empty. If I change the resolve strategy to delegate first, what we'll see is that we'll see different behavior. There we go. The buffer value is line 1 and line 2. And notice that line 6 up here never ever executed. Right? We never invoked the append method on the owner. Right? So there are 4 possible values for resolve strategy. And if you remember that every closure has an owner and every closure has a delegate, then it's easy to remember the 4 possible values for the resolve strategy because they are owner first, delegate first, and owner only and delegate only. The default is owner first, right? The default is owner first. And what that means is when line 11 executes, the owner gets the first opportunity to respond to that method call. He gets first crack at it. And if he can handle it, that's what happens. If the owner cannot respond to that method call, then the delegate gets an opportunity to respond to the method call. If the delegate can respond, that's what happens. And if the delegate can't respond to the method call, then you'll get a missing method exception. If we did foo bar, now we're going to get a missing method exception, right? Missing method exception, no signature of method foo, this right here. So both the owner and the delegate, they each got an opportunity to respond to that method call, but neither could, right? Neither of them has a foo method, so we got an exception. Right? Get this back in a functioning state here. There we go. Questions or comments about any of that? Yeah. Am I going to cover what? I didn't hear the very beginning of the question. You said, am I going to?
Can we implement our own strategies?
Okay, the question is, can you implement your own strategies for this? And you can't really implement your own strategies, but you can implement your own delegate and do whatever you want to do in response to these method calls. But you don't get to really plug in whole new strategies. The resolve strategy is one of 4 things. It's either owner first, delegate first, owner only, or delegate only. And all the behavior that I just described applies there. Yep. Anything else? All right, let's keep pressing on then. All right, so there's a class class provided by Groovy called the MarkupBuilder. It's in the groovy.xml package, which isn't represented there. It's called the MarkupBuilder, and the way the MarkupBuilder works is you can create an instance of that class and invoke methods that don't exist, like music, right? There's no music method in the MarkupBuilder class, but I can invoke that method and pass a closure as an argument, and that closure can invoke other methods that don't exist, like metal and prog, and these can be nested arbitrarily deep. The result of executing the code on the left is the markup on the right is generated. The markup on the right is generated as the result of the code on the left. So the way this works, by the way, this is just a super simple, fantastic way to generate markup from Groovy, right? Any of you who have generated markup from Java and using JAXP or some API like that appreciate how tedious and crazy that is. This could barely be simpler, right? All that same complicated stuff is still happening, but you don't have to write any of the code to make that happen. The way this works is the MarkupBuilder it doesn't really have a method missing in it. It has a method called invoke method, but we'll just, for the sake of keeping scope managed in here, we'll say that the MarkupBuilder has a method missing in it. It could have been implemented that way. So when you invoke the music method, that's invoking method missing. Method missing looks at the method name and creates a new element, a new XML element, and that is the music element. Then the method missing will look at the argument and recognize that it's a closure, and it will invoke that closure. But before invoking the closure, the method missing has to set the delegate on that closure to be this, meaning the MarkupBuilder itself. Because when the closure is executed, the first thing it does is invokes the metal method, which doesn't exist. So the delegate needs to be in place to intercept that method call so we can carry on with processing. When that happens, the delegate is assigned to the closure, the MarkupBuilder assigns itself to be the delegate of the closure and then executes the closure. So the call to metal is going to go back to that same method missing that intercepted the music method call. So another element is created, and the MarkupBuilder is keeping track of context, and it knows we're inside the music element, so it creates a metal element and adds it as a child of the music element, and then rinse and repeat, right? It can be arbitrarily deep, and but we've seen basically most of the pieces of the puzzle that it would take to write a class like the MarkupBuilder. Right? And there are there's JSON builders and markup builders. There's a swing builder for building Java swing interfaces, and the builder pattern shows up all over the place in dynamic languages and in Groovy in particular. Does that make sense? All right, one more example of that. So inside of a Grails application, if we're not in a Grails application right now, but inside of a Grails application, if you define a domain class like person and assign values to or define properties like first name, last name, and age. All right, something like this. All right, so I've defined some constraints here. So in Grails, when you define a domain class, you can do something like this. You can declare a constraints property and assign it a closure. And inside of that closure, you can you're declaratively expressing some rules for what are valid values for these properties. So we've expressed that the age has to be at least 5 characters and no more than 45 characters. And the first name has to begin with an uppercase J, some arbitrary regex there. But I've expressed some rules. If we look at this and think about what would happen at runtime when this code executes, this is really a method call, right? The parens are optional, so maybe it doesn't look like a method call, but it is, right? We're invoking a method called age and passing, it's a map that can have any number of entries, right? I can say nullable, true, what else could I say about an age? So that's enough, right? So I can apply any number of constraints there. So I'm invoking the age method and passing a map as an argument, but there is no age method, right? We don't see an age method anywhere. There is no age method. So what Grails is doing early on in the application lifecycle, as your application is being bootstrapped, is we go through all of the domain classes in the app and look at each of them to see if they define this constraints property. And if they do, Grails grabs this closure and executes it. But before executing the closure, the framework has to assign a value to the delegate. We need to intercept that call to age, right? And we need to intercept the call to the first name method. So a delegate is assigned to this closure before it's executed, and that delegate has method missing in it. So that method missing, that's easy to say, that method missing is being invoked here. So that method missing looks at the method name age, and it knows what class you invoke this method, it knows what class this constraints block is in. So the delegate will go look to verify that there really is an age property in this class, and there is. Kind of separate from this, Grails is building up the mapping, is building up a model of how this class will be mapped to the database. So you've invoked this age method, and the delegate will verify that there really is an age property, and then it might go get access to the ORM configuration for this particular property and manipulate it to have some of this data, right? And so the system knows that the age property has to be between 5 and 45, that it has to match a certain regular expression or whatever you've expressed in your constraints. But the method missing and closure delegates is what makes that possible, right? It turns out that's how lots of DSLs are implemented in Groovy, is using exactly the ideas that we're talking about. And this is a DSL, right? The D, the domain, is constraints, where we've got a language here for describing what are valid values for these properties, right? And Groovy makes all that, just the simple things that we've looked at so far is what makes that possible. Thoughts or comments about any of that? Yeah.
All the parentheses are not very Groovy, they are acceptable. You can't put parentheses around it, just like it's a regular method, right?
The question is, while the parens are optional, they are valid, right? And the answer is yes. So anytime you make a method call in Groovy and you're passing arguments, the parens are optional. The and you're passing arguments is important. If you're invoking a method and not passing arguments, the parens have to be there, otherwise it looks like property access. So anytime you're invoking a method from Groovy, even if it's on a Java object, it doesn't matter what language is at the other end. If the method call is being made from Groovy and you're passing arguments, the parens are optional. And generally, I don't put them there. I'm probably not, maybe I'm a little bit inconsistent with that, but in general, I think the code looks better without the parens. It's just less ink on the page. Ken?
Did you say what the delegate was inside the constraint closure or not?
As the author of this, do you get to say that? Is that the question?
No, what is the delegate?
Yeah, the question is what is the delegate that is being assigned to this closure? And it's a class that's part of the Grails framework. So as a Grails application developer, you don't have to know or care about that. In fact, you don't have to know how all this works, right? Understanding how it works is helpful if you want to build your own DSLs for this sort of thing. But there's a class inside of Grails, I think it's called the default constraints builder or something like that. But as a Grails application developer, that's an implementation detail and is subject to change. Yeah? Yes. The question is there missing property similar to missing method? And the answer is yes, but it's not missing property, it's property missing. So if you did this, if you said property missing, string prop name, that will only be called when you retrieve the value of a property that does not exist, as opposed to this, which will be called anytime you retrieve the value of a property. Right? And then if this has 2 arguments, that will be called, the method on line 15 will be called anytime you assign a value to a property that doesn't exist. Right? In the expando case, we want to intercept all property access, not just, there are no properties that you really want to access in the expando class. So all property access is being intercepted here. Yeah. It is. The question is, so in Grails, you can define a config file, and in that config file, you can do things like grails.server.port.http equals 8082, whatever. And you can just make up your own. They don't have to be, that happens to be a property that's meaningful to Grails, but you, in a Grails config file, I could say, Jeff, that'll work, right? And yeah, absolutely. So those property access, there's a class that's part of Groovy called config object, and it's intercepting that property access and building nested maps up. And yeah, so the techniques that we're talking about now are what make that possible. I want to leave this in a functional state. There we go. Other questions before I move on? All right. Very good. We're covering a lot of cool ground here. All right, Groovy module extension. Let's see. I want to cover one other thing, and before we do that, we're going to come back to Groovy module extensions. That's important stuff, but I want to introduce one other idea before we do that. All right. Let's see. Let's do that. So name equals Zach, and I want to interrogate that object at runtime and find out what type of object it is. And it's an instance of java.lang.string. Java.lang.string. It's the same string class that Java developers are used to using. Groovy doesn't have its own version of that. It's just a java.lang.string. So anything I can do with the java.lang.string, I can do with this thing because that's what this is, right? So I can call substring. I can call to uppercase. It really is an instance of java.lang.string. If I were to do something like this, say string.metaclass.do something equals, there we go. So we'll call name.doSomething. I made a typo, but I'll be consistent. We'll just say I did that on purpose. There we go. Doing it. So that worked. This is invoking a method that doesn't exist. Right? There is no do something method in the string class. But what I've done right here is I've added a method to the string class. And this is a really important and powerful idea that Groovy supports. Groovy makes it really trivial to modify classes at runtime. And that includes things like adding methods to classes at runtime, replacing existing methods to classes at runtime. So here we're adding a new method, right? We're adding a method called do something to the string class. From Groovy's perspective, every class has a meta class associated with it. Not just Groovy classes, all classes have a meta class associated with them. So string falls in that category. So I can refer to string.metaclass, and that is the meta class that's associated with java.lang.string. And then I can interact with that thing in ways that are very similar to what we were doing earlier with the expando. And that is, I can just make up a property, do something, and assign it a value. Thought I was going to be able to ignore that, but I can't. I can just make up a property, like do something, and assign it a value. And the value I'm assigning it is a closure. So what I've done there is, it's as if I've added a method to java.lang.string. I've added a method to the string class. So name is an example of a string, right? That is a java.lang.string. So when I invoke this method, this is what happens, right? Questions about that so far?
So class from Java can also access this method?
Yeah, the question is, can Java code access this method also? Practically the answer is no. You can, but yeah, it's a funky thing you have to do, right? You have to call into the Groovy system. You have to write code that calls into the Groovy system that says, go find this, go execute this do something method. If you wrote Java code that tried to do this, the code wouldn't even compile, right? Because there is no do something method in the string class. So the Java compiler says, I don't know what you're trying to do here, but I don't like it. So your code won't compile. If you were using this technique to replace an existing method, like to uppercase as an example, your Java code would compile because to uppercase is a valid method on the string class. But when your Java code calls to uppercase, it's calling the real to uppercase. It's not going to get this dynamic method that you added at runtime, which is one of the limitations of Groovy's runtime metaprogramming capabilities. So all this stuff we're talking about can be applied to Java classes. And we're going to see an example of that coming up. And here is an example, right? String is a Java class. But the runtime metaprogramming stuff that we're talking about is not accessible from Java. It can be applied to Java classes, as we are here, but it doesn't apply to method calls that come from Java. Because when you compile your Java code, the compiler generates instructions that says, go execute the to uppercase method in the string class. When you compile that same line of code in Groovy, the compiler generates instructions that says, send a request to the MOP. Tell it that I want to invoke a method called to uppercase on this object, and then the MOP has a whole bunch of stuff it's going to do. And one of the things that the MOP is going to do is it's going to look at the meta class to see if there's a to uppercase method, and if there is, that's going to be executed, not the to uppercase method that is in the string.java source code. Does that make sense? Yep.
So does it make sense to think about do we need to apply the metaprogramming to the classes versus the object?
You said, do we need to apply what?
Do we need to think about where the metaprogramming goes in the class or against the object?
Yeah, so I think the question is, do we need to think about where and when you do the metaprogramming? Is that what you're asking?
Can we do the metaprogramming? So we can do the metaprogramming in the object also, but on main,
Like this right here? Is that the question? Yeah, so you can do that. So what I had before, this is modifying the meta class that's associated with java.lang.string. So I'm affecting all strings, even strings that were created before line 3 happened, right? If that's not what I want to do, one other option I've got is Groovy supports per instance meta classes. So if I do this, now I've only added the method to the meta class for this particular string. And I almost never do this. So it's, you can create screwy enough stuff doing this, right? Modifying the strings meta class. If you start modifying individual instances meta classes, one issue is if you've got a lot of that going on, like in a web app, you're going to consume a lot more memory than you might otherwise have. But even that aside, if you've got two instances of the same class and they have fundamentally different behaviors, you can really get really hard to reason about stuff. So this will work and it'll function, but you really need a good reason to start doing per instance meta class programming, and which brings up the point that all the stuff that we're talking about, especially replacing existing methods at runtime, is a really powerful tool to have, and there are lots of really interesting ways to take advantage of this. But there are also some really nutty things you could do that just wreak havoc and make your system practically unreasonable, right? You won't be able to reason about your system. Don't do that, right? Use your power for good and not for evil. But runtime metaprogramming is one thing that you really need to be careful about. Things can get out of control, and you can build a system that's unmanageable. So don't be afraid of doing runtime metaprogramming, but make sure what you're doing is sensible, and don't do crazy things. It's good that you've got these really sharp tools. You just have to walk around the house carefully with them. Other questions about this? Yeah. Does it have a performance impact? And it does. And let's take a look at that. So let me do. It's a good example here. Let me cover another couple of points, and we're going to come back to that. We're going to introduce something that will improve the performance with respect to this. So I'm going to come back to that point. All right. So I've added a method to the string class. So let's add another method to the string class that does something like this. All right, let's see what that does. So the output there is axe. It's the Pig Latin version of Zach, right? And because of Groovy's property access, I can shorten this. Instead of calling get Pig Latin, I can refer to the Pig Latin property, and that too will work. So what I've done now is I've added a method called getPigLatin to java.lang.string. So all strings have a method called getPigLatin, and the implementation of the method is what you see here. Remember the closure delegate that we talked about before. All closures have a delegate. Here we're inside of a closure, right? So there's a delegate in that context. When you do this kind of this style of runtime metaprogramming, what will happen when this method is invoked, right? So here, remember that we're invoking a method. When that method is invoked, it's a request to you're sending a request to the MOP to say, here's an object, here's a method name, and maybe here's some arguments. Try to make that happen. One of the things that the MOP is going to do is it's going to look at this object and discover that it's a java.lang.string. So then it will go out and look to retrieve the meta class associated with java.lang.string. And if that meta class knows how to respond to the getPigLatin method, then that's what's going to happen. So the runtime is going to get a reference to this closure and execute it. But before executing it, the delegate will be assigned a value, and the delegate will be whatever object the method was invoked on. So the delegate is actually the string Jeff. It's the string Zach, right? It's the string that the method was invoked on. So delegate 1 will evaluate to ACK, right? It's everything after the first character. Delegate sub 0 will evaluate to Z, and then we've got the literal AY hard-coded there. So we get ACK, then Z, and then Y, and that's consistent with our output. If we did this right here, so it is the implicit first argument to a closure. So we're trying to invoke getAt on null. So no argument, no value is being passed as an argument into this closure. And that's important because the method could accept arguments. So if you were, let's do this. Let me add a different method. Let me get this back to functioning here. All right, let's add another method that says string.metaclass.repeat int I return delegate times I. All right. Now if I were to println name.repeat 4. Right, we get Zach. So the argument here is not Zach. It's whatever's passed to the method invocation, right? So you can't refer to it. It is a different thing. It would be the default argument here. I could get rid of that and use it in this context. That'll work, right? Does that make sense? Other questions about any of that? Yeah. If you want to inject state, a statement. So give me an example of a state. So this is a statement, right? So there's a method defined in source code somewhere, and you want to add something to the middle of that method call. You can do exactly that with compile time metaprogramming, but not with runtime metaprogramming. Demonstrating how you do that is, we don't have time to get into that, but you can definitely do that. We do that all over the place in the Grails framework. We put code in places where you haven't written source code. So you can modify existing code, you can replace existing code, you can add new instructions at compile time, but you can't do that at runtime. You're operating at the method level. You can add a whole method, you can replace a whole method, but you can't get in the middle of a method and do anything. Anything else? Yeah.
What is the default value of delegate when the closure is created?
So you're talking about the case where you've created a closure. We're not talking about the meta class stuff. You're just saying like C equals that.
Well, I guess in most cases, actually.
Yeah, so if you do this, what you're going to see, right? So it's the owner, right? Well, you can't tell from looking at that, but that's what it is. It's the thing that created the closure. So when you create a closure, the delegate is effectively it's the same thing as the owner, unless you assign a different value to the delegate, right? But in this case, when you're doing this, it's a different thing, right? By the time your closure executes, the delegate will always be the thing that the method was invoked on. That's because Groovy is doing that, right? Before Groovy executes the closure, it assigns a value to the delegate, and the value will be this thing, whatever name points to. Yeah?
If you have a class that's annotated with compile static, can you do runtime metaprogramming on that class?
The question is, if you have a class that is annotated with compile static, can you do runtime metaprogramming on that class? You can, depending on what you mean. Depends on what the meaning of the word is. So if you have a class that's annotated with compile static, you can do this sort of thing to it. And when you interact with that object, all this behavior we're talking about will work. What you cannot do is from inside of that class take advantage of runtime metaprogramming. Because when you annotate your class with compile static, what you're doing is you're telling the compiler that when it compiles that class, all the stuff that's inside the class, all those method dispatches will be statically dispatched. So they're not requests to the MOP. It's more like what happens when you compile Java code. Yeah. You understand the distinction between metaprogramming inside that class and taking advantage of metaprogramming that's been applied to that class? Right. Yeah. Does that make sense? Good. Anything else? All right. Again, remember that what we're doing here, we're interacting with the string class. The string class is a Java class. It's not a Groovy class. All of this runtime metaprogramming stuff can be applied to classes written in any language. What's important is that the interaction is initiated from Groovy. This is Groovy code right here. That's a request to the MOP to carry out this method invocation, and runtime metaprogramming techniques like this apply when you do that. Right? All right. Let's look at Groovy module extensions. So let's say that I want to add methods to a class at runtime, but I don't want to have to do use the technique that we just looked at. I want to provide a library that will do that same sort of thing. So you can write a class like this. So just write a class that has static methods in it. The first argument to the method represents the type that you want to add this method to. So I want to add a method called SumMethod to the SumClass, right? So somebody else wrote SumClass. Maybe it's part of the JDK or it's part of Hibernate. It's part of some library, and you've got a method you want to add to that class, but you can't, right? You didn't write the class. Maybe you could create a subclass of that class and add your method there, but that wouldn't make all the instances in the JVM of the original class become instances of your class, right? Your new behavior would only apply to instances of your class. So you want to add a method to some existing class, but you can't add the method to that class's source code. One way to do that is the meta class interaction stuff we just looked at. Another way is with Groovy's module extension system. So you write a class, just a plain Groovy class, define static methods in the class, and the first argument to the method represents the type that you want to add this method to. So I want to add a method called SumMethod to the SumClass, and the SumMethod accepts no arguments. The way to tell Groovy that this class exists and that it is in fact a Groovy module extension is under metainf/services. If you create a file called org.codehouse.groovy.runtime.extension module, it doesn't look like a file name, but it is, right? The file name is org.codehouse.groovy.runtime.extension module. Create a file with that name under metainf/services, and you assign the module a name. You can assign the module a version number. The important part, the interesting part, is the last line there that says extension classes. So that's a comma-separated list of classes. There's only one here, but it's a comma-separated list of classes. At runtime, if this is on your class path, Groovy will discover it using Java's service locator API stuff. Groovy will discover this extension module file and read it, and it will load up all of the classes that are listed as extension classes, and it will process all of them. And what processing them means is it'll look through the SumExtension class and look for all these static methods, and when it finds this SumMethod method, it looks at the first argument, SumClass. So Groovy does some metaprogramming. It's as if you did SumClass.metaclass.SumMethod equals closure. Groovy will take care of that for you. You don't have to write that imperative code. You write the module extension and this descriptor, the service descriptor, and Groovy will find that and make it happen. So let's exercise that in some real code here. So I've got I'll do this with a Java class, just to be clear that you can do this with Java classes as well. So I've got a Java class called company. A company has a name, and companies have a number of employees, and then we've got getters and setters for all those, and this main method is of no consequence, we can get rid of that. Right, so just a POJO, a Java class that has a couple of properties, and those properties have getters and setters. Right, let's create a class. Actually, I've already got a class. We'll add a method to this company extension class. And the word extension is not magic here. That's just a reasonable name. You can call the class anything you like. But I can say static int company. And I want to return c.number of employees times 2. All right. So what that's going to do is that's going to add a method called getNumber of employees. It's going to add a method with this name to this class at runtime, and this is the implementation of that method. Right? We need to go edit that service file that I described earlier. This guy right here. So I've already written that. So we've got the module name is company extension. The module version is 1.0. This is the important part, right? Extension classes, and if I had another one, demo.2, demo.3, and so forth, right? This is just a comma-separated list of classes. You can list as many as you like there. But company extension is the only one that we're authoring here. Groovy will find that class, this file, as long as it's on the class path at runtime, and do the metaprogramming necessary to make sure that this method gets added to this class. So let's verify that that really does work. Yeah, the question is if the method needed to accept arguments, is this how you do it? And the answer is yes. Right? The first argument represents the type that the method's going to be added to, and every subsequent argument are actual arguments that you might pass to the method call. So it does the thing that seems the most reasonable there. You were able to guess correctly. That's good. All right. Def C equals new company, number of employees, 21. Then C dot, what did I call the method? We'll get rid of the get. We want to use slick property access equals 42. That's what I expect to happen, right? Let's start by commenting this out. We don't want the method there at first. Let's run this test, and we should get a missing property exception. Because there we go, missing property exception, no such property, double number of employees. There is no double number of employees property in the company class. But if I uncomment this extension method and run our test, there we go, the test passed. Right? So again, the steps to make that happen are you want to author a class that has these methods, it has methods in it, they have to be static. They're not actually static methods at runtime, they're instance methods, but they have to be defined in this class as static. The first argument to the method represents the type that the method will be added to, and that can be an interface, it can be a class, it can be anything, any type. Any subsequent arguments are actual arguments to the method, so if you had a method that needed to accept 2 arguments, there would actually be 3 arguments here. The first one is the type, and then the second 2 are the actual arguments. So you've defined this extension class, and then you need to tell Groovy about it. And the way to tell Groovy about it is create a file in metainf/services. The file needs to be org.codehouse.groovy.runtime.extension module. That's the name the file has to have. And there are properties you can assign values to. The one that we're interested in here is extension classes. There's another property we can assign a value to that is static extension classes. And it works exactly the same way as extension classes, but that's the way to add static methods to a class dynamically at runtime. Right? So static extension classes instead of extension classes is how you do that. Yeah?
IDE support for Groovy provide me, I guess, support for discovering where, like, when these extension methods are being called and, like, where they're implemented. So can I, use, like, the village declaration feature in Eclipse to find out that method X is implemented by this extension module?
Right. So the question is, are IDEs aware of this in such a way that you can navigate to the method and autocomplete and things like that? And the answer is I don't think so. I don't think IntelliJ does that, and I don't think GTTS does that. They could conceivably, as long as this is available in the project, but I don't think either of them do that. But they could. It would be complicated, but they could. Yeah? You would. So it's a good question. We're going to talk about traits. So the question is, would you still use this now that Groovy has traits? And you would. You could. They serve related and somewhat overlapping, but not the same purposes, right? So one thing you might do is maybe you're developing a library that adds behavior to some other library or some classes that are in the JDK. So let's say you want to provide a library that adds methods to the string class. So you write a class like this that defines methods that will be added to the string class, and you jar that up along with your metainf/services this descriptor file. You put that in a jar file and now publish that. Put that out in Maven Central or whatever. You distribute that jar file to folks. Now, if I pull your jar file into my project, and I don't do anything at all except for put your jar on the class path of my project, I don't do anything other than put your jar on the class path of my project. The methods that you defined that you wanted added to the string class will be added to the string class. You can't do that with traits, right? The author of the string class could say that the string class implements trait, which won't work because string's written in Java. Yes, so they're addressing different use cases, right?
In that case, what would happen if you include 2 jars that provide 2 methods in the string class, which have the same name, the same arguments, but different extension classes?
Yeah, so the question is, what happens if you're using 2 different libraries that do the same sort of thing and they provide conflicting methods? And I don't know the answer to that, but I expect what probably happens is the last one loaded wins, and I don't know what it would take to participate in deciding. Maybe it's the last one on the class path would make sense, but we'd have to test that. I don't know the answer to that. Yeah. All right, but let's talk about traits. That's important stuff, and we've got just about enough time to do that. All right, so I am going to let's go over here to our test folder. What have we got? We've got our company spec here. We'll use this spec just so I don't have to create another one. Let's say class, instructor. I'm going to do all this in the same source file just so it's easier for us to look at it, but these typically would be defined in different source files. do something like that. All right, so we've got that. That's not going to work, right? That test is going to fail because there is no magic number property on the instructor class. To run that, I've got an error someplace. Let's see what we've got here. Trait magic, why won't that work? How can I already, oh, I do already have a magic number trait. Let's just rename this one because I want to keep all this in the same source file. I have a trait defined someplace else called magic number. All right, there we go. This test is not going to pass, right? We get a missing property exception, no such property magic number on class instructor. This right here is problematic. I've created an instance of the instructor class and I've tried to retrieve a value of a property that doesn't exist. As the author of the instructor class, I can do something like this. New magic number. Now I expect the test to pass. If I can get it to run. There we go. All right, the test did just pass, right? So we change this. We'll say the magic number is not 42, it's 2112. Now the test will fail, right? And if I change my expectation, now the test will pass. All right, so what's happening there is happening at compile time. This is not runtime metaprogramming. This is the only bit of compile time programming we're going to talk about. The compiler is adding this method to this class. So if we looked in the bytecode for the instructor class, the actual bytecode that's on the file system, this method is in that class, right? And you can do things like refer to this, and the compiler knows what to do with that, right? That will, at runtime, that will evaluate to the instructor, not the new magic number, right? So a lot of cool, complicated stuff's going on there. Traits are a way to deal with, to do things that you wouldn't otherwise be able to do with a single inheritance language. So Java is a single inheritance language. You can only have one parent class, but you can have any number of traits, right? So I can implement that trait and some other trait, like that. I can implement any number of traits, and all the behavior in all those classes is being compiled into the instructor class. It's happening at compile time. One consequence of that is if I've got Java code that wants to interact with this instructor class, the Java code can call the getMagicNumber method because it's really in the bytecode, right? So a statically dispatched language like Java can call this method on an instructor. Does that make sense? That's cool stuff. You can also do runtime trait stuff. Let's do this. Let's get back to our failing test mode. So instructor does not implement the trait. We got a missing property exception there. So if we were to do something like this, let me change the way this test is written. We'll say def I equals new instructor. Then I.magicNumber is 412. So instructor does not implement anything, right? So it doesn't have the new magic number trait applied to it. And maybe instructor is part of the JDK or some library. So I don't get the opportunity to change the source code for the instructor class. But I've got an instance of the instructor class, and I'd like to treat it as if it implemented that trait. I'd like that trait behavior added to this object at runtime. And a way to do that is I2 equals I.withTraits, new magic number. Down here and do that. Let's make sure that works. It should work. There, and it did. Right? So I is an instance of the instructor class. So I've invoked the withTraits method on I. This is happening at runtime, of course. This is not compile time stuff. And passed a list of traits. In this case, there's just one element in the list. What's returned from that is a thing that has all the same behavior as I, and it also has the trait behavior associated with it. If I were to interrogate this thing, I2 instance of new magic number, it is in fact an instance of new magic number, so I can invoke methods like getMagicNumber. If the instructor class had methods in it, I can invoke that method. I can say i2.getSomething, right? I can do that. I should be able to do that. There we go. So far, so good. The surprising bit, or the bit that you need to be aware of, is this will not be true. Seems like that should be true, but that's not true. That failed. I2, in fact, is not an instructor. I is an instructor, but I2 is not. The thing that's returned from with traits can't be an instructor. What if the instructor class was final? Like if it was java.lang.string. We can't create a thing that extends java.lang.string. So the thing that I2 points to, the thing that's returned from the with traits method is a proxy that implements all of these traits. So it has all the trait behavior, and it has a reference to I. It's not I, and it's not a subclass of the class that I is an instance of. It has a reference to I, and it delegates to it. So when you invoke i2.getSomething, the code inside of the proxy is actually delegating that off to the instructor. So this eventually gets called. But this thing right here, the object that I2 points to is not, in fact, an instructor. Because of the way the proxy generation works, it can't be. So what it is an instance of some class you don't care about. It's a proxy class. It implements all of these traits, and it also implements all of the interfaces that instructor implements. So if instructor implements interfaces like serializable or any interfaces at all, the proxy will implement those interfaces. But the proxy is not an instance of instructor, and it's not an instance of some subclass of instructor. So this bit right here is kind of the gotcha that you have to be aware of when you're doing runtime trait stuff. Yeah?
But will it return true instance of all the traits, the list with traits?
Yes, that's what's going on here.
So if there's more than one, it'll...
Yeah, so if we added another trait, all right, so we've got a getTown method in another trait. We want to add getTown here. Another trait here. No, I'm at the wrong line of code here. Up here is where I want the other traits. What did I call it? Another trait. Got a typo there. Right? So now I can do, what did I say? GetTown is STL. We can assert that i2.town is equal to STL. That'll pass. This will pass. And we'll just assert that this is not true. So that test will pass. So let's run that. Make sure that I'm not just making stuff up here. But the proxy implements all of the interfaces that the instructor class implements, and it implements all the traits that are in that list, and has all the behaviors associated with those traits. So we're interacting with a method from each of the two traits, as well as a method that's defined in the real instructor class, right? GetSomething is defined in the instructor class. Magic number is defined in the new magic number trait, and town is defined in the another trait. Yeah?
Do the traits have access to the property class that they're being implemented?
They do, because you can refer to this. So you have to be careful with that, right? Because you don't know what type the trait is going to be applied to. So if you refer to this dot some property that doesn't exist, you're going to get a missing property exception at runtime. Right? Yeah?
Out of curiosity, so there's a lot of parallels, if you think about Java doing mixes with AOP. Is it essentially the same thing versus runtime versus compile time?
Yeah.
Runtime traits and
Yeah, so I think the question is, how does this relate to, say, using AOP in Java, right? And with AOP in Java, what you can do things like intercept method calls and do something when you intercept method calls. I don't think libraries like Spring AOP allow you to do things like simulate multiple inheritance and add new methods to classes. I'm sorry?
So I believe you can do introductions which has the same behaviors, where you get an object back
Right?
Same behavior.
So the way that Spring AOP in particular works, right? There might be other AOP libraries that behave differently. Is Spring AOP has two mechanisms for generating the proxy, right? If the class that's being proxied implements interfaces, then what will happen is, I'm forgetting the details, but the two different paths you can end up with is the proxy might be a class that extends the class that's being proxied, and it might not. It might be a class that does not extend the class that's being proxied. It just implements all the interfaces that that class implements. Yeah, if I thought about that, I could remember the details. But there are two different proxy mechanisms. One generates a subclass and one does not in Spring AOP. Other thoughts or questions about any of this? It's really cool stuff. So one of the things, and just a couple of comments to wrap up here, is in Grails, there are lots of places where runtime metaprogramming happens. And there's also a lot of places where compile time metaprogramming happens. So when you define a domain class, for example, at compile time, in recent versions of Grails, at compile time, we add methods to your domain class like get and list and count, things like that. There are lots of things we do to your controllers at compile time, and services and tag libs and so forth. There's a lot of stuff going on at compile time. There's also a lot of runtime metaprogramming going on. So as we bootstrap the application, we iterate over all of your domain classes and do a certain amount of runtime metaprogramming. And that's what happens in Grails 2. One of the things that's kind of actively in development right now with in the Grails 3 code base is we're trying to minimize runtime metaprogramming. In particular, trying to minimize the metaclass interaction stuff that Grails does now. And as much of that as we can implement at compile time, that's what's being done. There are some things that just can't be done at compile time, and those are still going to have to be runtime. But instead of domain class.metaclass.method equals closure, like we demonstrated here, instead of that, all of that's being replaced with this type of stuff, right? We're writing modules, extension modules that get applied to certain types of classes inside of your Grails app. So traits were introduced in Groovy 2.3? 2.3, I think, is the version of Groovy that we introduced traits. Prior to that, Groovy didn't support traits, but Grails needed that kind of behavior, right? We have behavior that we add to lots of different artifact types. There are lots of methods that we add to all controllers and methods that we add to all of your tag libs. The language didn't support traits. So internally inside of Grails, there's really no good way for you to tap into this and take advantage of it. But inside of Grails, we kind of have our own trait implementation. We apply traits, you could call them traits, to your Grails artifacts. Because Groovy 2.3 has formal support for traits, one of the things that's happening in Grails 3 right now is we're replacing our own semi-trait system with real traits. So at runtime, if you were to interrogate your controller, you'll see that your controller implements grails.artifact.controller or something like that. I forget the package, but it implements controller. Controller is actually a trait that's defined inside of the core of Grails, and that trait is being added to your controller class at compile time without you having to write in your source code, my controller implements controller, right? At compile time, we know how to identify all of your controllers, and we're adding the trait. We're making it as if you had said, my controller implements Grails.artifact controller. So traits we've got a good bit of work to make it all function, but in the end, we're going to end up with a much simpler code base because we get to yank out all of our own trait stuff. Just take us a little bit of work to get there. So it's an example, and this happens all the time, but it's an example of the language evolving in ways that simplify the implementation of the framework while adding more capabilities from the perspective of folks using the framework. So traits are awesome stuff. It's probably one of the biggest, most important features that have been added to the language lately. Just great stuff. Lots of interesting ways to take advantage of traits. So comments or questions about metaprogramming in general, or anything at all that I've talked about this afternoon? Yeah. Performance, yeah. So when you make every method call you make from Groovy is a request to the MOP to say, hey, go carry out this method call. And those calls are more expensive. They're more performance expensive than statically dispatched method calls. For some time now, Groovy has had support for static compilation, right? You can annotate a class or you can annotate a method with compile static. And what that tells the compiler to do is don't do any of the MOP stuff, right? When you compile this method call, make it a static method call. And you also get type checking, right? So if you've made a typo in the method name, the compiler will fail, which is not what happens in normal Groovy. In normal Groovy, it's okay if you make a typo in a method name. It's okay as far as the compiler is concerned, because there are lots of places where you really do want to call methods that don't exist. So the compiler allows that. If your class is annotated with that compile static, and you try to call a method that doesn't exist, the code won't compile, right? And that's on purpose. So you've expressed that you want this method call to be statically dispatched, and it can't be because the method doesn't exist. So you get a compile error instead of a runtime error. You also give up the ability to intentionally call methods that don't exist, right? If your class is annotated with compile static, you can't do things like invoke dynamic finders in Grails and interact with the expando class and refer to things that don't exist. Inside the context of Grails, we've introduced our own compile static. It's called Grails compile static, and it does allow you to do some of those things. It allows you to call dynamic finders and call certain kinds of methods that don't exist, and those calls are just being dynamically dispatched, and the rest of the class is being statically compiled. So that's one part of the story, right? You can annotate a class with compile static, and what that means is you still get to take advantage of all the syntax stuff that Groovy has to offer. You can do anything that from a syntax perspective, you can do anything that Groovy supports. What you give up is dynamic dispatch within that class, right? Interactions with that class are still subject to dynamic dispatch, but the code inside of the class that's marked with compile static is all static dispatch stuff. You're giving up dynamic dispatch. So you can't invoke methods that were added by extension modules. You can't invoke methods that were added using the techniques we saw, like string.metaclass.methodName. You give up dynamic dispatch within that class. And the other performance-related thing that I had in mind to demonstrate, but we just kind of ran out of time, is when you intercept a call to a method that doesn't exist, that's an expensive way to respond to that method call, because the runtime system has checked to see if the real method exists. There's a whole series of places that method might have been responded from. And at the end of the line is when method missing comes into play. So every time method missing responds to a method, it's kind of the most expensive way because you've gone through all this other stuff to get to method missing. So inside of method missing, what you can do is metaprogramming. Inside the method missing, you can add the method to the class using class.metaclass.methodName equals closure. So the very first time you call the method that doesn't exist, that goes to method missing. Method missing actually adds the method to the class. So the second time you call that same method, method missing is not involved. That sounds more complicated than it is. It's like 6 lines of code to make that happen. Yeah, so those are some things I can say about performance that relate to all of this. Anything else? All right, very good. I think it's, well, my phone says it's beer 30. Thank you all very much, and if I can help you with anything, let me know.